Hello, students. I hope that you had a wonderful weekend. We're going to get started with this week's lecture. It will probably be broken down into two parts, and we will be talking about Chapter 6 and the basic principles of cooking and food science. So let's get started. Here are your vocabulary terms. Please make sure to look at the textbook and make sure that you know all these definitions because you will definitely see them on the quiz and definitely on the exam, which actually is coming up fairly fast if you look forward on the syllabus. All right, so starting off, so what is your definition of cooking? So people have very, very different definitions. Some consider cooking if they put, Easy Mac into the microwave. Is that cooking? By definition. Some people consider making a salad cooking. They look at cooking as basically prepping a meal. Now, is that the same thing? Are those interchangeable? So when we actually look at the definition of cooking, so the definition of cooking is the application of controlled heat to food. So with this definition, for my two previous examples, actually the fact if somebody takes Easy Mac and puts it into a microwave, now that is using some sort of controlled heat and applying that to food. So technically that, yes, would be considered cooking. Now, while preparing a salad might require some incredible chopping skills like you just practiced in your past lab, unless there is heat involved, so unless there is something like a grilled chicken breast or the tuna steak or something associated with it, if you are not using applied heat, then technically it's called assembly. It's not really cooking. So what we're looking at is we need to be controlling the heat, applying it to food, and we're definitely creating a molecular change that we desire within food. So here comes the science aspect of cooking. So let's look at what heat actually is, okay? So once again, this might be something that you guys remember from maybe fourth grade science class, something along those lines. So what is heat? It's a form of energy associated with the motion of atoms or molecules. So that's basically what we're looking at. Now we have three different types of ways that we can conduct heat. We have convection, conduction, and radiation, and we will look at the definition of each of those. So when a substance absorbs heat, its molecules start moving faster, and that's kind of what happens. And the temperature is a measurement of molecular activity. So the faster the molecules move, the higher the temperature is. So obviously, when you actually see water come to a boiling point, you know that that's actually the atoms are moving much faster, so that is where the heat rises. So what must be controlled in order to control cooking, to control this heat? So time and temperature. So these are two things that are very important in cooking. They have to make sure that if we're calling for a recipe, and remember the whole thing is cooking is heat transfer, but it needs to be controlled. We need to be looking at how long we're cooking something for and also at what temperature. So those are the two things that we need to be looking at. And that's why most of your recipes will say something like bake this for 45 minutes at 350 or cook over medium heat until slightly thickened. All of those things will be controlling or telling you how to control time and temperature in order to get whatever item that you're cooking, the food, to a desired temperature. Okay, let's go back a little bit. Okay, so heat alters food's molecular structure. And what do we change? So we change texture, flavor, aroma, and appearance. And one of the examples that I love to use for this molecular change that happens is the onion. So while many of you guys may love raw onion and it goes great on hamburgers, it's something that definitely changes drastically based on how you cook it and for how long you cook it. Basically what kind of different methods we use for cooking. So we change the texture of it. We go from, using the onion as an example, from a very tough, structured item to something that becomes very, very loose, something that becomes very soft. Flavor, absolutely. We go from almost like a bitter, a little bit of a tangy on your, or maybe sometimes a lot, tangy on your tongue, to something that's very sweet, caramelized, absolutely delicious. Aroma, appearance, both things are changed when it comes to cooking after heat is applied. Now, this is not just an onion. You can think of so many different items that we use that go through these molecular changes, and that's really the reason that we do this. So why do we cook food? So here are obviously the 4 reasons that we look at why we cook food. Digestibility, that's a big one. Now, this is basically looking at how can we make it easier to eat something. So some things, when they're raw, they may not be as palatable. Something like a turnip or a parsnip. Those are great examples because when you eat them raw, they're actually not very good, very fibrous. The flavor is not very good. But yet when you cook them, they become completely different. Look at the raw chicken up there. So that means that even goes back to safety, but also palatability. It definitely doesn't taste good. Digestibility, it may not be great for your stomach either. Also to improve the appearance. A lot of times when you cook something, it becomes a desired appearance that we are looking for. So these are the 4 things that we use to basically what we want to do with food, the reason we cook them. And also, I guess, variety, because there are certain items that we can eat raw or cooked, and it gives us an option with our menu selection, I guess, that we can look at. Okay, so to cook successfully, understand what heat does to the major components of food. So we need to understand what actually happens when we cook to make sure that we cook successfully, and also that we use the proper methods of cooking to cook those items. So in order to do that, we need to understand heat transfer and how that happens. So remember we talked last time about cooking with judgment. So definitely recipes cannot be 100% accurate. So there is some cooking knowledge that we must have as cooks and hopefully as chefs that we can exercise judgment based upon. So knowledge of ingredients and what method is best used to cook those ingredients, knowledge of cooking principles, and ultimately the experience of applying those principles to those ingredients. So let's look at the most important components of foods and what happens to them when we actually apply methods of cooking. Okay, so there are numerous things that happen when we apply heat to specific things, and the first thing we look at is protein. So what happens to proteins is they actually coagulate. So whenever you are cooking a protein and it becomes or goes through the method of cooking, we say that they coagulate. So truly, if you're a server and you are asking your customers how they would like their steak prepared, you can start asking them, well, how would you like your proteins coagulated? Because that's actually what happens if you are cooking a piece of steak. We also have carbohydrates, so we have starches and sugars, and so the starches tend to gelatinize and sugars tend to caramelize when you apply heat. Fiber breaks down unless sugar is present, but fiber is basically, I gave the example beforehand of something like a turnip or a parsnip. Even think of a carrot. So it definitely, if you apply heat, it becomes softer. Fats melt, but they don't evaporate, and that's an example of if you're melting butter. And water definitely evaporates. So the more heat that you apply to it, it comes to a boiling point, and then it starts essentially evaporating if it goes past the boiling point. And minerals, vitamins, color, flavor, those are all impacted, sometimes positively, sometimes negatively, but either way, we need to make sure that we understand what happens to them when we are selecting cooking methods. All right, so the goal of a cook is to maximize the positive effects of heat and to minimize the negative effects. So one of the things, especially when it comes to any type of food, do not overcook it. That's the number 1 rule as a cook. When you are applying heat, that time and temperature, so not all food requires high heat, not all food requires heat for a very long time. So it's something that we need to control. So that goes the judgment again of a cook. So now let's talk about the 3 ways in which heat is transferred. So we have 3 different ways, and one of which is always present, but 3 different ways in which we can actually conduct heat. So conduction, that's always present. And we'll talk about basically conduction and how it's always present. It basically is a transfer between 2 surfaces. So whether it's from a pan to an actual product, that's basically 2 surfaces are the ones that are exchanging the heat. Convection can either be natural or mechanical, and that is where basically there is some medium between the heat source and then the product, and that something happens in the middle. There's something that the heat travels through. Now, if it's natural, it could be something like water, or it could be something like air. If it's mechanical, something is aiding in this circulation, and that's when we think of something like a convection oven, and it has a fan in the back of the oven that helps it. And then radiation is basically, that's usually your infrared, and that's your microwave. So that's what most people think of when we think of that. So conduction, obviously, that's the transfer of heat from surface to surface, from the direct contact. So think of, you have a pan, and then you put an egg in the pan. So it's a contact, and it transfers heat that way. Convection, the transfer of heat through gases or liquids. So the perfect example is if we're taking an egg again, but this time we are boiling it. So we put it into a pot that is holding water. And then the water is actually our liquid that we are passing or transferring the heat from. And then finally, radiation, and that's the transfer of energy through waves of electromagnetic energy that travel rapidly through space. And then in a controlled environment like a microwave, that's how it's actually cooked. So conduction and convection, those two methods, the product that we are cooking is actually cooked from the outside in. So typically what happens in those products is the outside is typically a little bit more cooked than the inside. It seals whatever is inside, so it actually makes the inside nice and moist. Whereas radiation, it actually cooks from the inside out. So you cannot have something brown in a microwave. Now, can you get it fully cooked? Absolutely, but you will not have anything where it's cooking more so on the outside. This is also the reason if you're cooking anything in a microwave, it typically calls for you to mix it and then to restart it again, because the inside cooks first and then the outside, so you have to mix it in order to distribute what has already cooked throughout. So when is something done? We mentioned this a little bit last class. You know, it's the interior temperature becomes a desired temperature. Now, for specific reasons, such as when we cook poultry, right? It's kind of like embedded in everybody's mind. It should be 165 or higher, 165 or higher. And basically, the reason for that is because there's a specific temperature at which bacteria can no longer live, so that you are ensured that you are not spreading some sort of disease. Now, as far as everything else, just looking at this chart of how some of you might like your steak, there are times where it just depends on what the desired temperature, meaning the desired temperature of the guest or of you, is. It's much more complicated than it seems, and those of you that ever tried to grill a steak between mid-rare and, medium and medium well and medium well to well, it definitely takes some practice as far as cooking. All right, so let's look at the factors that affect cooking times. Obviously, the cooking temperature, the speed of heat transfer, size, temperature, individual characteristics of food, all of those things impact on how little or how long we need to cook something for. So in the next video, we are going to look at the differences between moist heat cooking and dry heat cooking, and dry heat with fat cooking.